Hello and welcome to my video on measuring angles. Today we're going to look at how to measure angles in degrees using a tool called a protractor. So before we get started, I wanted to quickly go over some important parts of the protractor. The first is the center point. The center point is where the 90-degree line and the zero edge or the baseline intersect, and you can see that I have it circled here in my picture. This is a very important part of the protractor because this is where you're going to place your vertex when you're measuring. The second part I want to show you is the baseline. So that is that, it's called the baseline or the 100 or the zero edge line. Sometimes it's the 180 degree line, but normally it's the zero edge or the baseline. And that's the line that runs along the bottom of your protractor, which can be a 0 degree line or a 180 degree line, depending on which scale you're using. So there are two scales on your protractor. There is an inner scale and an outer scale. So the outer scale I've marked in green, and it runs from 0 to 180 degrees, going clockwise. And the inner scale I've marked in red, and it goes from 0 to 180 degrees, going counterclockwise. So you'll see that for above all numbers except for the number 90, which is in the same place whether you use the inner or the outer scale, there are two numbers that you could use when you're measuring angle. Now this is something that can sometimes get tricky when students are learning to measure angles, but we're going to talk about when to use which scale further along in the video. Okay, so now I'm going to show you how to measure your angles using a protractor. So the first step of actually measuring your angles using a protractor is to not actually use the protractor at all. What you're going to do first is you're going to go through and classify all of your angles by their angle size. So using what you've already learned about angles to name them as either acute or obtuse or a right or a straight. And this is going to help you later on. So the first thing I'm going to go through is do my classification. So this is my first angle. Okay, I can see that it is less than 90 degrees, and if I wanted to, I could actually go and get that tool that we used in estimating angles to prove to ourselves that yes, this is in fact less than a 90-degree angle. So this is of course an acute angle. Okay, I'm going to go over here to my second angle. Okay, this one is a large angle, so it is an obtuse angle. And I know that an obtuse angle is larger than 90 degrees, but it is smaller than 180 degrees. And then finally, I've got an angle over here. It's kind of upside down, and sometimes you can see angles like that, and it's not a big deal because I can always just, if it was confusing me, I can always just turn my paper upside down. So I can take a look here. I can see that it is larger than a 90-degree angle, which of course means it's another obtuse angle. And we're going to be coming back to this classification in a little bit. So it's very important that your first step is always classify your angles. Okay, so our second step is going to be to take our the center point of your protractor. So this one, some protractors have like a little hole. Ours does not. This one just has sort of a T there. So I'm going to put the base of that T right on my vertex. Okay, and it doesn't matter how I do it right away. I just want to make sure that I don't have to worry about any other line. The only thing I need to do is make sure it's right on my vertex. So now I can see that yes, my center point is on my vertex, so I'm ready to go on to the next step. Okay, at this point, I'm going to take that bottom arm, that bottom side of my angle, and I'm going to make sure that I'm going to align it, okay, so it completely matches up with my baseline, which is also called a zero edge line sometimes. So that line at the base of my protractor, okay, not the bottom edge, not this straight edge at the bottom, okay, I'm not talking about this one, I'm talking about the baseline, okay, that runs all the way through that 180 degree line or that zero edge line. So I'm going to get that on my protractor, and then I'm just going to rotate it around until that bottom edge completely lines up. Okay. And at this point, my next step is going to be to just following that top line up, that top ray up, all the way up. And I'm going to see, so this is the 70 degrees, okay, and this one is 80 degrees. So I'm just 1 larger than 70 degrees. So I would say that this is in fact a 71-degree angle. But what I have to do now is I have to think, am I right? Am I right? Because what kind of angle is this? Is this an acute angle or an obtuse angle? Because there are 2 scales on this protractor. And it is just as easy for me to say it's a 71-degree angle as it really is for me to say it's a 109-degree angle if I use the outer scale and not the inner scale. So because I know that this is an acute angle, I know that it can't be 109 degrees. I know it has to be 71 degrees because 110 degrees or 109 degrees would be an obtuse angle. So that's why that classification is so important. So that last step is, of course, to make sure, does my answer make sense? Does my degrees match with what I know is an acute angle? Okay, let's go over and try this one over here. So I know this one is an obtuse angle. I know this angle is an obtuse angle, and I'm going to keep that in the back of my mind when I'm measuring, because I know for sure that an obtuse angle is larger than 90 degrees but less than 180. Okay, so I'm going to take my center point, I'm going to put it on my vertex, and then I'm going to rotate until my baseline is completely lined up with the bottom of my bottom ray of my angle. And then I'm just going to measure, follow that line up all the way. So it's passing through the 130 and it's passing through the 50, maybe closer to the 51, but I'd be okay with 50. So I have to think to myself, is it 130 degrees or is it 50 degrees? Well, it's an obtuse angle, so I know it can't be 50. 50 angle's really small, right? I mean, we know that that's like half of a 90, so it has to be 130 degrees. Oops, 130 degrees. Okay, and finally I'm going to look at this last one. So I can flip my protractor around and I can do it like that, but now I'm looking at numbers upside down, and I find it's just so much easier when I have an angle that looks like that to just turn my paper all the way upside down to do my measuring. So again, I'm going to look at putting my center point right on my vertex there. I'm going to rotate my protractor around so it lines up with my bottom edge, my baseline there, okay, or my zero edge. And I'm going to follow my other ray all the way up, and it goes right through the 110 and right through the 70. So again, I'm thinking here, is it 70 or is it 110? Well, let's go back. We said it was an obtuse angle, which means it has to be 110 degrees. And that is how you use a protractor to measure angles in degrees.